All right. This is an Algebra 2 problem that I've been given. The equation is x to the fourth power minus 65x squared equals negative 64. This is definitely not your conventional type of equation in that I see one term right here with a degree of 4 followed by just another higher level exponent right here in the second term. So something that I've always been in the habit of doing is when I see terms that usually have exponents that have degrees of greater than 1 is I want to think about moving the negative 64 to the other side so I can get an equation that's equal to 0 in the end. So when I do that, I'm actually going to add 64 to each side. Okay. And so what I end up getting is x to the fourth minus 65x squared plus 64 equals 0. Okay, now think for a moment. That actually still, you might think to yourself, wow, that's actually still really complicated because I still have these exponents and these terms with degrees that are greater than 2. I don't see, it looks kind of like a trinomial, but it isn't really. But wait a second. Let's pretend for a moment, and I'm just going to make a little thought cloud. I do this a lot. Pretend for a moment that that is x squared minus 65x plus 64 equals 0. Well, if that's the case, that's a lot easier to solve because, well, let's think of the factors of 64. That would be 1 times 64 and 8 times 8 and etc. There's going to be a bunch of them. Well, I already see one pair of factors that if I combine them in some way will give me 65. So that must mean that, and I notice that the sign is positive, so the binomial, or resulting binomials, have to be negative in this case because I see that the second term is this really large negative, and then the factors are going to be 1 and 64. It doesn't really matter of the order. But the problem is, right, that it's not like that, right? This isn't the case. We actually have, back to reality, this x to the fourth minus 65x squared plus 64 equals 0. So if you actually multiply this out, though, what if I actually made, going back to my original equation, if I see those two binomials, what happens if I actually, well, what if I actually just add two exponents? It's x squared minus 1 and x squared minus 64. Well, watch what happens. So I'm going to make my little box. I like using the box method over FOIL. You'll see why someday. Okay, I have x squared minus 1 across the top and x squared minus 64 along the left column. I get x to the fourth minus x squared, or minus 1x squared, minus 64x squared, or yeah, and then plus 64. Well, these combine to get x to the fourth minus 65x squared plus 64. Well, does that match my equation up here? It does. So that is actually the binomial that I have. So I have x squared minus 1, x squared minus 64 equals 0. Well, excellent. So But wait a minute, the actual question isn't can you factor this out? It's give me all the possible values of x, right? Okay, so let's move to the next slide. I'm going to make another slide. All right. So x squared minus 1, x squared minus 64 equals 0. So think about that for a second. If you remember, our original trinomial is x to the fourth minus 65x squared plus 64. Based on this exponent, I know that I have 4 zeros. This is the fundamental theorem of algebra. So that means, looking at the binomials, I should have 4 distinct zeros, right? Well, 4 zeros. Whether they're distinct or not is another matter, right? However, I know that either if I took this, that has to be 0, or this has to be 0, or both are 0. So I've got my two equations. I've got x squared minus 1 equals 0. And x squared minus 64 equals 0. So let's work on the left equation first. So I'm going to add 1 to both sides. I get x squared equals 1. Take the square root. End up with x equals 1. Now here's a trap answer. Don't forget that it's actually plus or minus 1. Because if I take negative 1 squared, that also is 1. Just as if 1 squared is 1, right? The tendency is just to think, oh, it's only positive 1. Okay? Now we're going to look at the other equation, and I haven't been using my colors, so I'm actually going to do that. So I'm going to add 64 to both sides. When I do that, I get x squared equals 64. Take the square root. I end up getting x equals plus minus 8. So my zeros, if I were to enter this with a series of, the way that it was formatted in the homework assignment, it was x equals 1, negative 1, 8, and negative 8.